So here are quick examples for derivative of function. First example is constant function 2020. So this is a constant function. So graph is just a horizontal line that passes 2020. So geometrically, derivative stands for slope of the tangent line. And whenever you pick a point, slope of the tangent line is always 0 because all lines are horizontal. So you may easily guess that derivative of this function is 0. Well, actually, you can even calculate. So by definition, f prime is limit of. So by definition, you want to take this limit. But our function is constant. So this numerator becomes 2020 minus 2020 over h. So numerator is already 0. So f prime is already 0. So f prime is 0. Second example is linear function with the slope 1. So the line passes the origin. So for this function, you want to find the derivative of this function. And geometrically, you want to look at slope of the tangent lines. I mean, whenever you pick a point, tangent line is already this line or has a slope 1. So you may easily guess the derivative of this function is 1. You can even calculate by taking the limit f of x plus h minus f of x over h. Now that our function is just x, f of whatever is whatever. So we have numerator, and after canceling, we have h over h. So our expression is just 1 automatically. So so the limit is 1. That means f prime is 1. Okay, so for the next example, let us use a quadratic function. So let me use quadratic function x squared. And the graph is parabola. So as you see, we have a curve. So when you take derivative, it's not going to be 0 or constant function. So we will have some function other than constant function for this x squared. So we want to take limit carefully to find the derivative. So by definition, f prime is the limit so f of whatever is whatever squared. So we have x plus h squared minus x squared over h. To get simple expression, you FOIL this or expand, distribute, and we have x squared 2xh h squared minus x squared. Now you see canceling pair. After canceling this copy of x, we have 2xh plus h squared over h. To reduce this expression further, you can factor. So common factor is h. So if you factor, we have 2x plus h over h. We're almost done. Once you cancel this copy of h, we have 2x plus h, but h is approaching 0. So basically, the resulting expression is just 2x. So this is 2x. So it turns out that derivative of this function is 2x.